For years, if you heard AI, you pictured some theoretical breakthrough, maybe way off in the future. But if you're actually a developer, someone building and shipping software day to day, AI isn't the next frontier anymore. It's here. It's a set of tools ready to go. The tricky part is connecting those tools into your apps without, spending weeks fighting with all these different proprietary APIs.
And that's precisely where Spring AI comes in. I mean, if you're already working within the Spring ecosystem, this set of libraries is basically designed to be your shortcut. It helps programmers like us grab onto popular AI platforms. It could be a chat model, image generation, even transcription. And it does this by giving you a single, clean way to interact, hiding all that vendor-specific mess.
Right. So our mission today, our deep dive, is pretty straightforward. We're looking at how Spring AI gives us these cohesive abstractions, how
Yeah.
it bridges the Spring apps we know and maybe love with big AI platforms like ChatGPT. We really want to focus on the practical stuff. The hands-on knowledge engineers need to actually start building AI features right away, turning these, advanced AI things into just another manageable Spring Bean. Okay, let's unpack this.
What's fascinating here, I think, is that the whole framework really boils down to a pretty simple core idea. You've got a model, it takes a request, they call it a prompt, and it gives you back a response. The clever bit is how Spring AI layers all the familiar Spring concepts, the things we already use, on top of that interaction with these, well, probabilistic models.
Yeah, and for developers who are, short on time, the main thing you need to grab onto is the chat client. That's the key abstraction. It's the workhorse, right? It handles the whole request response thing. It's your gateway. Doesn't matter if it's OpenAI or Hugging Face or Google on the other side. The complexity is hidden. You just deal with one consistent interface.
Exactly. And that prompt object, it's actually more powerful than it first looks. It's not just sending a string. No, it's an object where you set context, parameters, configuration options. And this is really, really crucial for production systems. You have to control the cost.
Oh, absolutely. Let's dig into cost management for a second, because that's something that easily trips teams up when they move from, say, a dev sandbox to the real world.
Mhm.
You might set your default model in your application.properties, maybe something cheap and reliable like GPT 3.5 Turbo. But what if you have this one critical feature, maybe summarizing a complex legal doc that really needs the best quality model available?
Right. You definitely don't want to run that super expensive model for every single simple user chat message, but you need it on tap, right? Spring AI lets you do that. You can dynamically switch the model just for a specific request using configuration objects like OpenAI chat options. Imagine you get a sudden huge spike in, I don't know, basic chatbot queries. If you accidentally left GPT-4 running globally, well, you could wake up to a pretty shocking bill.
So that dynamic switching isn't just neat, it's actually a core risk management thing.
Precisely. It gives you that fine-grained control over costs right down to the feature level.
Okay, let's shift gears a bit to consistency. We're dealing with these probabilistic models, which by their nature can be a bit unpredictable. How does Spring AI give developers the levers they need to get predictable outputs, especially for things where consistency is king, like maybe data validation or some kind of automated decision?
Yeah, that's handled by the temperature setting. And this
Hmm.
is a detail developers really need to pay attention to, especially if you care about QA. It's a value usually between zero point 0 and 2.0. If you set that temperature right down to point 0, the model's answers become much more deterministic. They get predictable, consistent call after call with the same prompt, and that's essential for testing, for debugging, for getting repeatable results in a stable app.
Okay, but hold on. If I crank the temperature down to 0, doesn't that make the model maybe too rigid? Like, is there a risk it just gets stuck or refuses to answer if the perfect response isn't obvious from its training?
That's a really good point. It does reduce the creativity, let's say. But for a lot of bread and butter enterprise tasks generating standard code snippets, performing validation checks, that predictability is way more valuable than diversity. On the flip side, if you're building something to brainstorm, say, marketing slogans or story ideas,
Hmm.
yeah, you crank that temperature up to get more varied creative outputs. It's really about making an engineering trade-off based on what you actually need that feature to do.
That makes sense. It makes temperature feel less like some obscure statistic and
Yeah.
more like, well, part of the application's actual business logic you need to configure.
Exactly. It brings the probabilistic side of AI back into the developer's control zone.
Okay, let's get really tactical now. The classic problem with chatbots, or really any LLM, is that they kind of live in their own little world, right? It can tell me about history, but it can't check my current inventory levels or, flip a switch on the IoT device. How does Spring AI break the LLM out of that box and let it interact with our live systems, our databases, our devices?
This is where function calling comes in, and honestly, it's probably the most powerful feature for building apps that do real work. See, normal LLM queries are static. Function calling lets the AI decide dynamically, hey, I need to run some application code right now to get fresh data or actually do something.
And the way you implement it is just standard Spring stuff, right? No weird new language to learn.
Right. As a developer, you're basically just providing a standard named service method. It's just a Java interface, takes an input, returns an output, implements java.util.function, function tr, nothing fancy there. The really critical bit is the @description annotation you put on that function definition.
Okay, so that description is the hint. That's the documentation the AI actually reads.
It's more than a hint, it's the contract. It's what the LLM uses to figure out its internal routing. So if you describe a function like change a light state, the LLM can look at a user request like turn the yellow light on and tell me about the others, and it thinks, aha, before I answer, I need to call that update light status function.
Wow, okay. So that turns the LLM from just a knowledge base into more of a smart routing layer that can trigger your existing services. The light service example they used, managing yellow, red, green, blue lights, that nails it. The user just talks naturally, and the framework translates that into a specific function call that runs your actual code. This must be how production chatbots work when they check your order status or manage smart home devices.
Exactly. It means you, the developer, don't have to build complex, probably brittle natural language processing logic yourself. The LLM does the intent recognition part, and Spring handles the plumbing to execute the code.
Okay, here's where it gets really interesting for me as a developer. Moving away from trying to parse those sometimes messy natural language responses. For years we had to do all these prompt engineering tricks like respond only in valid JSON format, no extra words, start with a curly brace, and you just cross your fingers it actually worked.
Yeah, that whole era of fragile text parsing, we can mostly leave that behind now. With Spring AI, you just use .entityClass.class when you make the request. You give it a Java record class, like say light with XYZ list.class. And the LLM will actually try to format its output directly into an instance of that Java object.
That is a huge win. You immediately go from messing with regular expressions and string splitting, which is always prone to breaking, to proper object mapping and type safety. Huge.
And it's not just for simple data either. The sources showed how you can use a system message to specifically instruct the AI, hey, when you report the light status, also include the complex technical data, like the CIE 1931 color representation. If you're building an industrial control system, you need that precise data, the coordinates, not just blue. So this shows Spring AI is serious enough for real complex data extraction, not just, summarizing blog posts.
Okay, so we've nailed structured data output and calling real-time functions, but modern apps aren't just text fields anymore. What about audio? What about images? How does the framework handle that?
Yeah, moving beyond text is definitely key, and Spring AI covers quite a bit in this multimodal space. Let's touch on audio first. It covers both generating speech and understanding it.
Okay, text-to-speech. That's popping up everywhere for accessibility, for voice assistance. What does a developer need to know to use it here?
Well, there's the OpenAI audio speech model. It lets you generate pretty natural sounding speech using good models like TTS-1 or even TTS-01 HD. And importantly, you get control. You can pick specific voices. They have names like Alloy, Shimmer, and you choose the output format you need, maybe MP3 for web, maybe FLAC or WAV for higher quality. So you can tailor the audio to fit your app's needs or maybe bandwidth constraints.
And flipping that, transcription, using the Whisper model, which has a great reputation.
It does. I actually tried the example from the sources, the old Daisy Bell song.
Yeah.
What really stood out was how well the model inferred context. It knew when the lyrics meant the number 2 versus the word to, just based on the surrounding words. That kind of context awareness makes a big difference in accuracy, especially if you're using transcription for, say, automated meeting notes or analyzing content.
Makes sense. And visually, image generation seems standard now.
Yeah, Spring AI handles that through Dialy integration. You give it a text prompt, the framework handles the API calls, and you can tweak things like the quality standard or HD and the style. Maybe you want vivid or natural.
Okay.
But I think the most compelling visual piece is the multimodality recognition. This is where you mix data types in one go. The chat model isn't limited to just text prompts. It can take a text prompt and a media object, like a PNG or WebP image, together.
Like the light visualizer example they described. That seemed to tie everything together.
Exactly. It demonstrated the whole cycle. First, the AI checks the actual status of the lights using function calling, like we discussed. Then it generates an image of the light that's currently on. And finally, it uses image recognition to look at the image it just generated and describe it, basically confirming the system state visually. It's a pretty powerful pattern for testing and verifying these complex AI-driven systems.
Okay, if we connect this to the bigger picture,
Wow.
we really have to talk about how these tools change the game for engineers day to day, specifically the risks, the landscape you have to navigate when you start putting this stuff into production.
Yeah, this is super important. The first potential pitfall is around AI-generated code. The sources rightly warn that, okay, AI can generate code that works, maybe for some tricky parsing logic or something, but developers absolutely must not mistake accuracy for correctness. The code it spits out perfectly reflects any flaws in your prompt. Ask a vague or flawed question, you'll get flawlessly functional but ultimately wrong code back.
So you're saying human expertise is still critical. We still need to define the problem super clearly and meticulously verify the solution, especially checking for security holes in edge cases. Can't just copy, paste, and deploy.
Precisely. You're still the architect. You own the solution. And that thinking leads straight into the engineering risks around legal stuff and data compliance.
Right. When you're dealing with sensitive data, knowing where it goes is a huge concern.
It really is. If you send secure or private information, even if it's just temporarily, to an external service like ChatGPT, you immediately run into potential compliance issues. Think GDPR, CCPA, HIPAA. If that service logs your data, or worse, uses it to train its future models, you've basically lost control of potentially highly regulated information.
So the developer faces a critical choice: trade convenience for control or vice versa.
That's the crux of it. Now, you can maintain total control by running models locally using something like a llama, but you need to understand the trade-off there. Running a llama means swapping a maybe variable monthly API bill for a potentially hefty upfront investment in hardware. You need serious GPU power to run good LLMs locally. It stops being just a software problem and becomes an infrastructure challenge too.
And one last risk area: intellectual property,
Mm.
especially with generated assets.
Yeah, when you're generating images with Dalal, or maybe synthesizing voices with text-to-speech. These models were trained on vast data sets, potentially including copyrighted work artist styles, actors' voices. There's a real risk of IP infringement. So developers need to be constantly vigilant about the source of the models and the licensing terms for the output they generate. Can you actually use that image or voice clip in your commercial product? It adds a whole new layer of asset management and legal review to your development process.
So what does this all mean then? It sounds like Spring AI does a good job of hiding the API complexity, letting developers like us focus less on vendor specifics and more on building actual features using text, audio, images. It seems to make AI integration feel like a more standard, manageable part of the Spring toolkit we already use.
I think the core takeaway for any engineer diving into this is captured really well by a quote from one of the authors mentioned in the sources. He said something like, "I'm going to be very wary of large language models and AI in general until I find one that can say, I don't know, when I ask a question about a technical matter."
That idea, the failure mode, the I don't know, that's exactly where we need to focus as engineers building these systems. Think about that function calling mechanism we discussed. It relies on your application code to provide real-time data. But what happens if that function call fails? Maybe it returns null because the resource it's querying is missing, like asking for the status of a purple light when you only have red, yellow, and green. So here's the question for you to think about. How will you design your application layer to handle those failures gracefully? How do you stop the LLM from just making something up, fabricating an answer when a critical function call returns nothing, so you can maintain integrity and trust in your AI-driven features? That's your challenge from this deep dive. We'll see you next time.